Welcome to the KVP Physics Academy. Hello everyone. Welcome to the KVP Physics Academy. Today we are going to the study of the electrodynamics. Electrodynamics means ED, simple ED. This is a very important subject for exam point of view. Yes or no? Now, today we are going to start of the solution of the set question paper. Okay, we are taking some example of the set exam. What is the first question? 12 equal charges of a magnitude Q are kept at corners. 12, how many charges? 12 charges kept at a corner. Okay, what is the magnitude of the charge? Q. At a regular sided, regular polygon. Regular polygon means all sides are equal. All sides are equal. Sided polygon, one at each of corner. Okay, each and every corner we can place the Q amount of charge. What is the net force? What is the net force on a take charge capital Q, on a take charge capital Q at the center of polygon at a distance r? Center of polygon at a distance r. Suppose we consider 12 charges, we can place the capital Q at the center of this one. Center of this one, and what is the distance here? Small. Distance is smaller. Okay. Before solving this problem, we can see some cases for related with these questions. Okay. So many times that this type of question asked in many exams. Now, first one we can take here is a triangle. System is a triangle. We can place a equal magnitude of 3 charges at a corner of this triangle, and we can place one take charge capital Q. One take charge capital Q. Okay, whatever the take charge place at the center, we consider this one is a reference. This one is a reference, and remaining all considered as a center. Okay, now where we can find out the force? At capital Q. Capital Q. Hence we consider this is as a reference, and remaining what? How many number of charges are present? This we can consider as a center. Okay, always memorize. This reference don't affect any force on center. Whatever the force act on reference because of this remaining all charges, or because of remaining all centers. What is? Whatever the here center are present, all center extract some force on this capital Q. Capital Q. Why? Because we consider this one is a reference. Here we need to find out the force on this charge. Got it? Suppose we can take here is a reference, means we need to find out the whatever the force on the charge, remaining all considered as a center. Okay? Means all 3 charges affect some force on this Q. Got it? Now we know that force, Coulombic force, F is equal to KQ1 Q2 upon R square. KQ1 Q2 upon R square. Means here magnitude of charges increases, force also increases. First one, and the second one is the distance increase. Distance between them increases, force is the decreases. Yes or no? Suppose medium also change, at that time force also change, but we can take the F is equal to KQ2 upon R epsilon naught. Simply Q1 Q2 upon 4 pi epsilon naught R square. Means this is in a free space. This is in a free space. So here come to the point. Now F1. Suppose this one is the first charge, second charge, and third charge. Okay. F1 attract. Now this is a capital Q. This also capital Q. This also capital. Like charge, repulsion. Unlike charge, attraction. Like charge, attraction. Like charge, repulsion. Unlike charge, attraction. Means in this case, which charge attract to another charge? Center attract or repel to the reference. Attract or repel to the reference. Always memorize this thing. See here is capital Q, small q. It's a center. Whatever the effect, take on capital Q. See here, this one is a Q. Here also plus. Both are plus. So this plus Q charge repel to this one. Repel to this one. Means this charge is going in which direction? This direction. Why? Because of some force act on the charge on this one. Got it? Means F1 in the direction. Next, F3. Same. Again, like charge. Repulsion. This is going in the direction. Okay? Means this particle moving in this direction. Got it? And third one. The charge attracts some force on this one. This is going in this direction. Means on the charge, how many forces is acted? 3 forces will be acted. Okay. Now next one. Now what is the resultant force? Here is F1 and F3. F1 and F3. Here is a vector quantity. Vector, we can take the addition. Or here, what is the resultant of this vector? Resultant of this vector F13 in that direction. F13 in that direction. Okay, and F3 in downward direction. F3 in downward direction. Whatever the magnitude of this, we can find out and take the direction. Here force, we know that here ratio is 2 as 1. Centroid formula we can use here. Then we're getting here distance is 2, here distance is 1. Okay, means here all magnitude will be same. But here slightly distance is a distance. Hence net force, whatever the magnitude of F13 and whatever the magnitude of F2 will be same. Magnitude will be same. Here direction of this force upward, direction of this force downward. Means the net force on this one. We can apply the 15 downward, 15 upward. Net force on this particle rest. Means the net force 0 on this particle. Got it? Means F net at this center is equal to how much? 0. For triangle case. Similarly here also, this force in this direction. Means this Q charge repel to this one. Means this is moving in this direction because of this one. Second, this act on this direction. What is the resultant of this one? In that direction. Okay. Suppose as we consider 1, 2, then resultant F12 is in this direction. Got it? F1, F2. Next, F3, F4. What is the resultant here? F3 4 in upward direction, F1 2 in downward direction. Again, these two forces are balanced to each other, and the net force at the center, how much? 0. Next, here we can take the cubic system. All charges placed at a corner of equal magnitude. Means whatever the amount of force act on this capital Q is equal for all charges. Means they are cancelled to each other. And what is the net force at the center? Net force at the center for cube system, how much? 0. Cube system, 0. Got it? Next, we can take the pentagon. Means this force in that direction. This force in that direction. Okay. Means what is the resultant force? That direction. Means suppose we consider F12 in that direction. This will be 3, 4, 5. And 3 in that direction. 4 in that direction. 3 in this direction. 4 in that direction. And 5 in that direction. Means here is a 3, 4, 5 in the direction, 1, 2 in the direction. Means what is the net force again here? 1 in the direction, another in the direction. Net equal, balance. Then F net is equal to how much? 0 for this case. Next for hexagon, this force in the direction, this force in the direction. Next, this force in the direction, this force in the direction. Means what is the resultant here? In the direction. What is the resultant here? This one. Means these 4 forces, they are cancelled to each other. And what is the remaining 2? This force in the direction, this force in the direction. Got it? Means what is the F net here? F net. F net is equal to how much? 0. F net is equal to 0. Next for, we can take the here is a 7, 8, 9, 10, 11, anyone. But condition is, which condition is very important here? This must be regular, n-sided. Here is a 12-sided polygon. N-sided regular polygon. A regular polygon means all sides are equal. Then what is the net force at the center? 0. Always memorize this thing. Means we can take the 7 charge, 0. 8 charge, 0. 9 charge, 0. 10 charge, 0. 11, 0. 12. F net at the center. Once you understand this example, then directly we can write down what is the net force at the center. Net force at the center is equal to how much? 0. Okay. Generally, we can think here is a 12 charges. 12 charges means force F is equal to 12 charges. 12 K Q upon R square. Means so many students we can choose which option? B option is correct. Maximum. Okay. And someone may logic will be different. They can say that Q1 charge only act on this force K Q upon right now. But this one is not anyone is correct. Why? Because here is a regular polygon. System is not regular polygon. Then we are getting some answer another also. Okay, this is for force. Sometimes they ask for electric field also. Sometimes they ask for electric field also. Okay, electric field also we consider here center at a +1 charge. Now here plus Q charge. Q charge repel to this +1. This take charge. +1 considered as a take charge. Means again this one is a like charge away from the center. Means this in this direction. This one in this direction. This one in this direction. Again they are cancelled to each other. Means here electric field for this case 0. E net 0. Here E net 0. Here E net 0. Here E net Okay, H0. Here also, E net also is equal to 0. But it's same thing. But here is a capital Q charge placed at the center. In electric field, we consider a unit take charge only. Unit take charge for finding the electric field. That is the small difference between force and electric field. We know that F is equal to KQ, QE means one charge is less in electric field than force. Is here also net electric field. Net electric field is equal to how much? 0. Here also net electric field is equal to 0. Means in a regular polygon system, at the center electric field as well as force is equal to how much? 0. Force is equal to how much? 0. Suppose we can try to remove one charge. Remove one charge from this one. Then what is the force at the center? Means whatever the force getting because of one charge. Because of one charge. Suppose this is equal to KQ upon R square. Means we can, a system is a triangle, square, hexagon, pentagon, regular, any polygons. We can remove the one charge. How much force act on the center? Center is equal to K, capital Q, small q upon R square. Always remember, this system is a triangle, square, pentagon, hexagon, any one. What is the net force at the center? KQ upon R square. KQ upon R square for this. Next question. Again, set 2015. Set 2015. Two equal charges of magnitude Q are kept at a distance d apart along x-axis. Apart along x-axis. मतलब ये दोनों के बीच का distance कितना है? D है. Okay. Along x-axis. Now the electric field at a distance z. At a distance z. Z is a very greater than d. Means this distance. Suppose consider this one is a z-axis. This one is a z-axis, and this z distance is a very greater than this d. This d. Okay. Above the midpoint or the second one, they are. We need to find out what is the magnetic field at the middle of this distance d. Between the two charges, E1 is given by this one. Okay. Now see here. हमारे पास one charge है. This one is a charge Q. We need to find out what is the electric field at a distance R. What is the electric field at a distance R? What happened? This one is a charge. Okay. Here this field is a divergence. This field is divergence like a bulb. Yes or no? Means this flux is a scattering here. This scattering and some flux incident on this point. Incident on this point. इस पॉइंट पे हमें कब पता चलेगा कि यार ये वो यहाँ कुछ फील्ड इफेक्ट कर रहा है. ठीक है. आप कब समझ लेंगे कि यहाँ लाइट लग रहा है नहीं लग रहा है? जब वो आप वहां प्रेजेंट हो गए. जैसा ना आप यहाँ प्रेजेंट है, लाइट ऑन कर दिया, यस लाइट आ गई. आप यहाँ प्रेजेंट है, ऑफ कर दिया, यस लाइट ऑफ हो गई. ये कब पता चला? आपको रूम में है ही नहीं है, लाइट ऑन भी हो गया, ऑफ भी हो गया, कुछ आइडिया नहीं आ सकता. समझ में आएगा? मतलब आपको लाइट आ गई या नहीं आ गई, ये समझने के लिए आपको यहाँ प्रेजेंट होना चाहिए. यस और नो? सेम वे आपको यहाँ इलेक्ट्रिक फील्ड प्रेजेंट है कि नहीं है, ये देखने के लिए मुझे कुछ ना कुछ टेस्टिंग के लिए होना चाहिए. यस और नो? और इलेक्ट्रिक फील्ड में हम टेस्टिंग के लिए क्या जूम करते हैं? वी कैन कंसीडर यूनिट चार्ज. We can place a unit charge. Suppose here charge Q. Here charge Q. We need to find out what is the electric field at a point P. Electric field at a point P. Now here is no any one charge is present, but we consider that here is a one unit charge is present here. Yes or no? The charge is moving in away or toward of this field. Then we can say some field is affected on this charge. Got it? Means always memorize where we can find out the electric field. Assume that at that point unit charge is present. Unit charge is present. Okay. Then we can find out what is the electric field. E is equal to KQ upon R square. Okay. Now this charge, we need to find out what is the electric field here. Means which here in this case +1 is a reference. +1 is a reference. This one is a center. This one is a center. किसका इफेक्ट हो रहा है? प्लस क्यू का. किस पे हो रहा है? +1 के ऊपर हो रहा है. ठीक है. मतलब जिसका इफेक्ट हो रहा है उनको सेंटर कंसीडर कर लीजिए, जिसके ऊपर हो रहा है उसको रेफरेंस कंसीडर कर लीजिए. आगे समझ में? मतलब ये हमारा वो जो प्लस क्यू है किस पे इफेक्ट कर रहा? +1 पे इफेक्ट करेगा. ठीक है. तो +1 हो गया रेफरेंस. किससे वजह से हो रहा है? प्लस क्यू के वजह से हो रहा है, मतलब हो गया सेंटर्स. गॉट इट? हाँ. Then what is the electric field? KQ upon R square. Next one. This one is very important. Then this one is the center, this one is the reference. This center attract to the charge, repel to the charge. Attract to the charge or repel to the charge. Simple general life example लीजिए. Like charge, attraction, repulsion. Like charge, repulsion. यस और नो? अब सिंपल सी बात देखिए ना, क्लास में आप बैठेंगे, सेम पार्टिकल और सिटिंग नियर टू इच अदर, स्पार्किंग विल बी टेक प्लेस, यस और नो? लेकिन आपकी बेंच जो है अनदर पार्टिकल्स के क्लोज है, तो देखिए इन दिस केस अट्रैक्शन इज टेक प्लेस, रिपल्शन इज लेस, अट्रैक्शन इज टेक प्लेस, यस और नो? मतलब सेम पार्टिकल रिपल्शन, गॉट इट? मतलब ये जो पार्टिकल है वो उसे क्या करेगा, रिफ्लेक्ट करेगा, क्या करेगा, और रिपेल करेगा, ठीक है? लेकिन हमारा जो नेगेटिव चार्ज हो जाता हो, सपोज ये जो नेगेटिव चार्ज है, सपोज मान लीजिए जो नेगेटिव चार्ज है, तो ये चार्ज के लिए क्या करेगा, वो अट्रैक्ट करेगा, अट्रैक्ट करेगा, मतलब ये चार्ज कहाँ मूव होगा, उस डायरेक्शन। हियर इज अ प्लस क्यू, वो चार्ज उन्हीं को क्या करेगा, रिफ्लेक्ट करेगा, इन विच डायरेक्शन, पॉजिटिव x डायरेक्शन। गॉट इट? इज द प्रॉपर आइडिया हाउ टू फाइंड आउट द इलेक्ट्रिक फील्ड, वेयर वी कैन फाइंड आउट द इलेक्ट्रिक फील्ड कंसिडर एज द प्लस यूनिट चार्ज। गॉट इट? नाउ सी हियर, come to the point. Here is a two charge. We can apply some distance d between these two charges. Now consider this one is the center, and above the center we need to find out the electric field. Then what is the distance d? D can be distributed into two parts, d by 2 from the center. Okay. Now this is the z distance. Z is a very large as compared to the d. Okay. Now next. Here अभी तो कुछ नहीं है, अभी तो कुछ भी नहीं है, लेकिन हमें इलेक्ट्रिक फील्ड फाइंड आउट करने के लिए कुछ तो टेस्टिंग के लिए होना चाहिए, इसलिए हम इसे क्या कंसीडर करेंगे, +1 यूनिट चार्ज कंसीडर कर लेंगे, ठीक है? आप देखिए ये मेरा प्लस क्यू है, ए भी प्लस क्यू है, अट्रैक्शन रिपल्शन, दिस इज अ लाइक रिपल्शन, ओके? मतलब ये मेरा प्लस क्यू, इसे अट्रैक्ट करेगा, रिपल करेगा, ये सर ना, मतलब ये कहां जाएगा, इस डायरेक्शन से जाएगा, अगर समझ, बिकॉज ऑफ फर्स्ट चार्ज F1 in that direction. Sorry, E1 in that direction. You can study the electric field here. Second one, this one is a reference. Reference कुछ भी नहीं करेगा, बस वो देखता रहेगा क्या कर रहे हैं साइड वाले, बस that's it. Now this center, उसमें कितना फोर्स एक्ट करेगा, सॉरी इलेक्ट्रिक फील्ड एक्ट करेगा, किस डायरेक्शन से करेगा, इस डायरेक्शन से, yes or no? Means Q to act electric field or field in which direction, this direction, okay? Means A to in that direction. This one is a vector quantity. This is the does not going in along x-axis or y-axis. This component don't going in along any axis. Then we need to resolve this component. Okay. Now here this is equal to theta. Then this also theta. Yes or no? Because this one is the middle. Now this vector going away from this system. Take the opposite angle. Means this is equal to theta. Opposite angle theta. This is equal to theta, then opposite angle theta. Got it? Out of the system, opposite angle into the system. हमारे सिस्टम के अंदर ही चल रहा है, तो सेम एंगल लेना, मतलब क्या है, इस डायरेक्शन से मेरा इलेक्ट्रिक फील्ड है, तो मैं I will be take this theta. Means this is into the system, same angle. Into the system, same angle. Out of the system, opposite angle. Got it? Both? Now, this one is a resolution. Now, see here, just focus here. This electric field going in the direction. This electric field going in the direction. Okay. This is equal to theta. Then this also theta. This one is a E1 bar. This is a E2. Or we consider E. Why we can consider the E? First, find out what is the electric field. General. What is the electric field? E is equal to. Here, this distance is d by 2. This is a z. Then what is this distance? D by 2 plus z. Bracket is to 1 by 2, or suppose we can say this is nothing but r. This is nothing but r. Okay. What is this value is equal to r? Means how much force, how much electric field act on this point? E1 is equal to kq upon r square. What is the E2 electric field? E2 is equal to kq upon r square. Both charges are same. Smaller one, kq upon r square. R means a distance from this point to this point. Okay. This is only single charge, then we can take this one is a directly answer. Got it? Next, but here is a two charges are resolved, or this electric field going in between of two axes, then we need to resolve this component. This is equal to theta. Draw the parallel line to this one. This is equal to theta, then this also theta. Draw the parallel line here also. This is equal to theta, then this also theta. Okay, with this E1 is resolved into two parts. This one is the front side, E sin theta, and this one is a E cos theta. Similarly, here also E cos theta, and this one is a E sin theta. See here, Both E1, E2 have the same magnitude, different magnitude, same magnitude. Why? Because your charge magnitude will be same, distance also same. Both quantities are same. We know that the electric field is a dependence upon only two quantities. Got it? Means both are same, hence we can take E only. That's it. E1, E2 is replaced by E. Now here, the magnitude. This both theta are same. Both theta are same. Means sin theta are same. But your direction is opposite. Opposite. They are cancelled to each other. They are cancelled to each other. Means this component get cancelled. Now these two components in the same direction. Same direction. Addition. Opposition. Cancellation. Okay. Means here is a E cos theta. E cos theta plus E cos theta. E cos theta plus E cos theta. This one is a total E. This is a total E. Total electric field. How much electric field act on this one? These two components are cancelled. Whatever the electric field act on this charge, going in upward direction, or this particle moving in upward direction. E total is equal to this component plus this component. Why we can take the two times? Because both in a same direction. Why these two components are cancelled? Because they are opposite in direction and equal magnitude. Okay. Next, E total is equal to 1 plus 1, 2. What is the value of E? E is equal to KQ upon R square. R square means D by 2. Bracket square plus Z square. R square. R is equal to how much? R is equal to root. R is equal to root. Z square plus D square by 4. Okay? D square by 4. And what is the square? Square means power is 1 here. Power is 1. Got it. Next, how to find out the cos theta? Cos theta, we know that adjacent upon hypotenuse. What is the adjacent here? Z is adjacent. Z is adjacent for this one. And what is the hypotenuse? R. Hypotenuse R. Means this is equal to Z upon R. R means root Z square plus D square upon 4. D square upon 4. This can be written as 2 times K Q Z upon K Q Z upon here power 1. Here power 1 by 2. How much? Power is 3 by 2. Means Z square plus D square upon 4 bracket is 2. 3 by 2. Bracket is 2. 3 by 2. But they are given answer in which form? Answer in which form? R to the power 3 form. R to the power 3. Means Z square plus yes, Z square plus R square can be written. What is the final answer here? Final answer E total is equal to, yes, E total is equal to 2KQZ upon Z square plus D square upon 4 bracket is to 3 by 2. Okay. Any one option is matches with this answer? No, any one answer is matches with this one. Okay. इसमें तो कोई भी आंसर मैच ही नहीं हो रहा है. मतलब दो ऑप्शन हो सकते हैं. एक तो हमारा गलत हो सकता है या ऐसा ना हो. ये दोनों में कोई तो ऑप्शंस रहेगा ना. लेकिन एक मान लीजिए कि हमारे आंसर में यहाँ Z आ रहा है. यहाँ Z आ रहा है. और ये इसमें कौन सा भी आंसर देखिए, इसमें कहीं भी Z नहीं आ रहा. कहीं भी Z नहीं आ रहा. मतलब कोई तो एडजस्टमेंट Z के लिए हुई है. आ गया समझ में? ये देखिए, फिर आपका दिमाग थोड़ा सा एक्टिवेट होना चाहिए. आप समझ लिए Z जाना चाहिए है, तो कैसा निकाल सकते हो Z के लिए? तो उन्होंने कंडीशन दिया है, Z इज अ वेरी वेरी ग्रेटर देन D. Z इज अ वेरी वेरी ग्रेटर देन D. ओके, मींस Z is a very very greater than D by 2 is a very very smaller than Z. Yes or no? Z इससे ज्यादा D के ज्यादा है, तो इसका मतलब D by 2 से तो डेफिनेटली ज्यादा ही होगा. ठीक है, हम फिर नेक्स्ट क्या करेंगे, इसको Z स्क्वायर करेंगे. ठीक है, Z स्क्वायर कर दिया तो D square upon 4 is a very very smaller one. D by 2 is very very small. Squaring of this one again very very smaller one. Hence Z square plus D square by 4 can be written as simply Z square. Why? Because D square by 4 we can neglect it. Why? Because this one is a very very smaller value and this can be neglected. This can be written as Z square. This can be written as Z square. Means here this whole term replaced by Z square. Why? Because they are given condition Z square is very greater than D by 2. Z is very greater than D by 2. Means Z square is a very greater than D square by 4. Okay. Means this can be written as Z square. Then what is this? E total is equal to, yes, 2kqz upon Z square. Z square bracket is to 3 by 2. Z square bracket is to 3 by 2. Means these two get cancelled. Here we are getting Z cube. Here we are getting Z cube. Okay. One Z get cancelled. Means this is equal to how much? 2k cube upon Z square. 2k cube upon Z square. But we know that what is the value of k? K E total is equal to, yes, k is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. 2q upon Z square. 2q upon Z square. Which of the following option is correct one? Here, first option, 1 minute. E is equal to 1 by 4 pi epsilon naught 2q upon r to the power 3 by 2. Here we are getting r to the power 3 by 2, no problem. Z square plus d square bracket is to 3 by 2. But here r to the power 3 by 2. R to the power 3 by 2. And what is the value of r? R is equal to under root d by 2 bracket square plus z square. We can substitute the r square value. Then we are getting r cube, not r to the power 3 by 2. Hence this option is not correct. Okay. Here is a suppose like a z r cube form. Here z and here is r cube. Then this answer also correct one. Got it? But here they are given only r cube and then z is absent here. Means this option is not correct one. Next. Here is a 2. They are given 2. This is not a z. This means a 2 plus. 2 तो कोई आने का चांस होता ही नहीं है उसमें. मतलब ये भी आंसर गलत है. समझ में आ गया? और नेक्स्ट ऊपर z नहीं है. अब देखिए इसमें हमने अभी करेक्शन ले लिया. Z is a very greater than d by 2 means z square is a very greater than d square by 4. Here 2 and 1. This is the small difference here. But here how this 2 is coming here? Because this system is a discrete system. System is a discrete. We need to take 2 times. 2 times means this 2 component is survived. Hence we can take the 2. But a system is continuous. System is continuous. At that time, here we are getting infinite number of terms. Infinite number of terms. At that time, don't take 2. Just take d cos theta. For continuous, is replaced by d cos theta. For continuous case. But the system is a discrete. Take whatever the getting number 2, 1, 3, whatever this. We need to take this one. Then which of the following option is correct? Option number 1 is correct for this case. Next question. Set 2011. Set 2011 an infinitely long wire. Infinitely long wire. Line charge has a configuration, has a uniform linear charge density. Linear charge density lambda. Linear charge density lambda. If r is a distance, at the point from the wire, then magnitude of electric field at a distance is okay. Now we can say this as a distance r from this point of P from wire. Okay, this one is a long wire. What is the electric field at a point P? Electric field at a point. Okay, this system is like a cylinder. This system is like cylinder. This system is like cylinder. Okay. Now, a charge is flowing inside of this one, having the charge density is a lambda. Okay. And charge is present means electric field is creating. Electric field is creating, and we know that electric field is normal to the surface. Means this is the direction of E bar. This is the direction of E bar to the cylinder. Suppose you consider this one is cylinder. Then electric field is creating in the direction. Electric field is creating in the direction. Means each and every point on this surface, electric field is normal. Electric field is normal. And what is the area vector? Area vector. A bar also in same direction. Means what is the area vector for this case? We can find out the area vector at this point. This area vector here. Means what is the angle between them? Angle between them is equal to 0. Both are parallel to each other. Both are parallel to each other and perpendicular to the surface. Now we can use the Gauss theorem. Gauss theorem. Okay. Close integral E bar dot ds bar. Close integral E bar dot ds bar is equal to Q enclosed upon epsilon naught. Q enclosed upon epsilon naught. System is a uniform system. Uniform. We know that lambda is equal to Q upon length, means charge per unit length. Suppose system is a uniform, then we can write down Q is equal to Q is equal to lambda into L. Q is equal to lambda into L. Okay. And suppose system is a non-uniform, then we can take non-uniform. System is a non-uniform, then we can take Q is equal to lambda into dx. Lambda into dx for 1t. Means here lambda is not constant. Point to point, lambda will be variable. At that time, you can take the integration. If the system is uniform, no need to take integration. Simply write down the Q is equal to lambda L. Lambda L. L is the length of cylinder, length of wire. Got it? Next, E bar dot ds bar. Here, what is the angle between them? Angle between them is equal to 0. Means E bar dot ds bar can be written as EDS cos theta. Theta is equal to 0. Means this is a simply EDA or EDS. Now, here we can find out what is the electric field at that point. Means here we can draw the Gaussian. Draw the Gaussian. Means here each and every point on this Gaussian. Each and every point on the Gaussian. Electric field is constant. Electric field is constant. Then E we can take common out. E we can take common out. Integration ds is equal to, yes, Q is equal to, now we can take lambda into L. Lambda into L upon epsilon naught. Upon epsilon naught. Why can we take the lambda L? Because this one is a uniform charge distribution. E ds. Now system is a cylinder. System is cylinder. This one is a cylinder. Okay. Now in this case, we consider this one is a surface. This one is a surface. In this case, R is varying in the direction. R is varying in the direction. Z is varying in the direction. Pi is varying in the direction. Okay. Now here on a cylinder, R is constant. R is constant. Means only which component is variable for surface area. Z is variable in the direction. Z is variable in the direction. And pi is variable in the direction. Got it? Means here is a two length elements. Which one? Integration. Sorry. E integration. First length element in a circular. Circular R into d phi into dz is equal to lambda L upon epsilon naught. Got it? This one is a two length element. One varying in the direction. Another varying in circular. Circular R into d theta. Okay. Here length is 0 suppose. Here length is L. Means we can take limit 0 to L. And here R is constant. Each and every point on the surface. Means here is a pi varying from 0 to 2 pi. Means here we can write down A into 2 pi RL is equal to lambda L upon epsilon naught. Okay. This L get cancel. What is the electric field? Electric field E out is equal to, yes, lambda upon 2 pi epsilon naught. 2 pi epsilon naught R. Means what is the electric field? E out is directly proportional to 1 by electric field is directly proportional to 1 by R for wire system. Got it? A directly proportional to 1 by R. Which option is correct one here? Which of the following option is correct one? हम क्या करेंगे, पहले ऑप्शन करेक्ट होने से पहले कौन सा करेक्ट नहीं हो सकते पता फाइंड आउट करेंगे. सिंपल. 1 by R possible, no problem. 1 by R square also possible outside the system. Independent of R, this electric field also possible. Means electric is the proportional 1 by R. Already we can solve. 1 by R square also possible. 1 upon is the independent of R also possible. But 1 upon R cube is not possible in any case. In this option is definitely 100%. This one is not correct for any case. Got it? Now focus on second and fourth. This is also possible. In which case? Suppose we can take the solid sphere. Then what is the electric field? Solid sphere. Close integral E bar dot ds bar is equal to Q upon epsilon naught. We consider this one is a cylinder and we can take the point is here. Means this we can draw the Gaussian surface is this one. This Gaussian enclosed whole system. Whole system is all charge enclosed by this system. Means we can take the Q enclosed is equal to Q. And what is the LHS? Each and every point on this Gaussian electric field is constant. Means we can take common out. Next, what is the area for this case? Here area is a 2 pi RL. For spherical system 4 pi R square. 4 pi R square is equal to Q upon epsilon naught into G. Means what is the electric field? A directly proportional to 1 by R square. No problem. But in which case? Solid sphere. There's cylinder or slightly wire. What is wire? Nature. Cylinder. Electric field is 1 by R square. For which case? For solid sphere. Third one. This is independent of one. This is also possible. Okay. But in which case? See here. We consider the surface. Flat surface. Here is we getting two. Here we consider the Gaussian is a pillbox. Gaussian is a pillbox. Means here pillbox have the two areas. Okay. Now here electric field in the direction. Area vector in the direction. Okay, means here angle between them 0. Means A bar in the direction, E bar also in the direction. Means this is a for first top surface EA, bottom surface EA is equal to how much? Q by epsilon naught. But here EA plus EA. Why we can take EA plus EA? Because the angle between them is equal to how much? 0. It's simply EA. EA plus EA, 2EA. And this one is the surface. Then surface charge density, sigma into surface charge density, sigma is equal to Q upon A. Means Q is equal to sigma A. Okay. This A get cancel. Is what is the electric field? E is equal to sigma upon 2 epsilon naught. Means electric field for plane surface is directly proportional to, there is no any R is present, means R to the power 0, or E is equal to sigma by 2 epsilon naught. Okay. This is possible for line. This is possible for solid sphere. This is possible for plane. Got it? This is not possible for any cases. This is all cases for outside only, not for inside the system. All cases for outside the